Okay, today I want to look at energy. We're going to look at that in a couple ways. We're going to look at specific heat, which is going to tell, based on the substance you have, how is it going to change temperature as you add energy or take energy away. Okay, and so we have an equation for this. Q is equal to mc delta T. Okay, and these variables, Q is our energy or energy change, and that's going to be in joules of energy. And so the next part here is M is mass in grams, and this should make sense, right? If we have more mass of something, it's going to take more energy to change the temperature, so that's part of it. C here is what's called the specific heat capacity. This is going to be dependent on the type of substance you have. So water has its own characteristics, specific heat. Different metals, so on, will have their own specific heat, some value that relates energy change and temperature change. So specific heat and delta T. Anytime we have delta, that means change. This is going to be change in temperature, and that's always going to be delta T is delta anything is final minus initial. So in this case, it's temperature final minus your temperature initial. So depending on whether you're heating something up or cooling something down, that's going to be either positive or negative. Specific heat is always a positive value. Mass is always a positive value. So Q and delta T can be positive or negative. They're going to be the same thing though. So if you have a positive delta T, you're going to have a positive Q. Negative delta T, negative Q. Okay, so the sign of the energy, positive or negative, is going to tell you which direction, whether it's going into the substance, whether it's leaving the substance. Okay, and so just like a lot of the situations where we have a couple variables, you're going to have some of them and not one of them that you're trying to calculate for, we can solve for a couple things. So if we need to solve for how much energy, we need to know mass, specific heat, change in temperatures. That requires a final and initial. One thing I didn't mention, the change in temperature can either be Kelvin or Celsius. When we're talking about change, those are the same thing. Okay, but if you have, so we can start with that. So Q, if we're solving for Q would be mc delta T. But if we were trying to solve for mass, we would need some of the other variables. So we could rearrange this. So it always helps to start with the Q is equal to mc delta T equation. Rearrange the variables before we start putting numbers in. Just rearrange the variables to see what we need, and then we'll take care of the rest. So if we're trying to find mass, say, well, we need, that would be Q over C delta T. Okay, so if we know Q, C, and delta T, we could figure out what the mass of the substance had to be. If you're solving for C, okay, that would just be Q over M delta T. Okay, so if you know the energy change, you know the mass, you know the temperature change, you can figure out the specific heat of that substance. And even if you're trying to find delta T, okay, that would just be Q over MC. Okay, delta T, the other thing we could do is you could figure out the final or initial, so we can get your delta T. Once you have your delta T, if you know what you started with, you could figure out what it'll end up at. Okay, so those are the basic calculations we could do with our specific heat equation. Where it gets a little more interesting is we start talking about calorimetry. And so this is like the lab what we've done here. So basically what we're doing, we know water has a specific heat of 4.184. Okay, so the specific heat of water is 4.184. It's a pretty well established value. So by using this, we can use that factor for water to figure out something about other substances like a metal. Okay, so if we have water here, so what we need to know is the mass of the water. We could measure temperature of the water, so we just put a thermometer in. So it has a certain temperature. Let's say we're doing a piece of metal. Okay, so with a piece of metal, okay, there's some things that we can measure about that. So if we know mass, actually let's just say we're trying to solve for specific heat of the metal. So we need a couple things. We would need, so going back to our equation here, specific heat, Q over M delta T. So we need our Q, we need our M, we need our delta T. Mass is easy, right? We throw it on a scale. Change in temperature is easy. That is, you just take the temperature before and after, final minus initial. Q is a little trickier.